we place the iPhone on the resorter, and then we place the resorter on a height of 1.22 meters, and then we pull toward us the liquid of the resorter at a distance of 30 centimeters and with an angle of 30 degrees. Then we let it go at the distance that it was of 3.52 meters, and the data were exposed in the application that we will show you later. And then we use the theorem of the energy work. This means that work is equal to the energy final minus the energy initial, but we don't have this energy, so this means 0. And then the energy is a kinetic energy, so we use this formula and we place here instead of this, and we want to know the acceleration, and the acceleration we can have with the data that we're showing in the table of the application. And then we substitute that work is force multiplied by distance is equal to 1/2 meters multiplied by the final velocity 2 times. Then we eliminate these meters, and we only have this one, but we still don't know how much acceleration is. So we're going to our data of the iPhone application, and we have to multiply by 9.81 because the data were exposed with a g's, and we need like in vectors only. So we're going to have the magnitude here, and then now I already know the acceleration, so we can replace it and we have the final velocity. These are our data of the application of the iPhone. This means that x-axis is 6.925, the y-axis is 1.955. These are the data that we got from the application of the iPhone, and this means that in the x-axis it was 6.925, in the y-axis is 1.935, and in the z-axis is 1.123, and then all of these we multiplied each one by 9.81 meters over seconds to the 2, and this means that the gravity, as I mentioned previously, the application only calculate this data with as g, and now we have to transfer it like to the vector. So we transfer it here to the magnitude formula, because we want only the acceleration in number, not in vector. So we have to substitute in the magnitude formula, and then we got this. And then finally, we can, to know the final velocity, we substitute here in this formula, now we have the acceleration and the distance. We substitute and we get that this is the final velocity.